I am here to discuss the so-called flying saucers.
The whole fleet of them, look on the SA. My gosh.
Unidentified.
The acquisition of unwarranted influence, whether sought or unsought, by the military-industrial complex.
Anomalous.
We have spacecraft from another species.
We do, yeah.
How many?
Quite a number.
Since 1947, we have received and analyzed between 1 and 2,000 reports that have been made by credible observers of relatively incredible things.
Podcast.
Hello everybody and welcome to this very special edition of the Unidentified Anomalous Podcast, and probably, I hope, it's going to be my favourite to date. Tom, who have we got coming on the show today?
Professor Avi Loeb. I am ecstatic for this. I've been wanting to talk to this man for a very, very long time.
I share your sentiment, and if I could drop my mic, I would, but it's on an arm, so I can't. I'm so looking forward to this one. I have to say a massive thank you to Professor Loeb as well, because he was in the space the other day, which I joined in on, and I decided to just drop him an email afterwards with the hope that he might decide to come on the show, and he responded to me within about 10 minutes. So I really appreciate it.
That's pretty great. He seems like a really, really friendly individual also, aside from being obviously just extremely bright and motivated. And we're going to open up the conversation today with something a little unexpected and a little bit interesting that I have in my back pocket that will hopefully plant the seeds for a really, really good conversation between us today.
Yes, I'm really looking forward to it. So without further ado, let's move over to Professor Avi Loeb.
This week's guest.
Professor Loeb, thank you so much for coming on and agreeing to speak to us today. I know I speak for myself and for Tom and for the rest of the community, actually, about how much it means to all of us. You know, everybody looks to you with a very good light and looks to you for an awful lot of answers. So I'm so pleased to have you on the show with us today.
Thanks for having me. It's a great pleasure.
Very welcome. I think we should start off with some questions, don't you, Tom? And do you want to go first?
Yeah, I thought this would be a really interesting way to kind of open up our conversation. I'm a big fan of the work of philosopher Bernardo Kastrup, and I was curious to hear your thoughts on the idea that materialism is currently on its deathbed because it doesn't necessarily answer all of the questions that we have about reality and the universe. I'm curious what your thoughts would be on that.
Well, I'm a scientist. And, in science, we study materialistic things. Now, given our experience with artificial intelligence, we are on the verge of making a machine, a technological product that is even smarter than we are. And my guess is that it will teach us humility in the sense that once we have ChatGPT 5 and higher levels, it will be able to do things which not only resemble humans, but actually supersede human capabilities in some areas. And it will basically give us the impression when you interact with those AI systems that, it may have some kind of a soul of its own. It may have the ability to surprise you, to behave as if it has free will, in the sense that you would not be able to forecast why it makes this or that decision. It will have insights similar to those that you find when you meet a person. Now, what will that tell you? We know that this machine was made of silicon. So how is it possible that it comes up with an interaction? Text, in this case, it's textual. It's just based on text. It's nothing physical. Of course, we need to wait for robots to do what we are doing, and that will take more time. But as of our emotional attachment, people might get attached to the machine, might fall in love with it because it understands them better than their partners, and you will develop a relationship with those very advanced AI systems. And so, to me, it would illustrate that yes, it's all made of silicon in the case of the machine because we built it, and in case of our bodies, it's nature that put them together, and I wouldn't assume that it's any different. That I would say, most of our body is water. We know that 2/3 of our body is water, and the rest are all kinds of chemicals and molecules that, when put together, behave in a way that we find intelligent and we find surprising and we find unpredictable, and we want to believe that there is something spiritual to it, something beyond the physical constituents. But the message we will get from AI is that no, it's an illusion. It's the same as the illusion when you see art. You know that the art is composed of material, right? A painter, some Van Gogh or Picasso, they use paint that you can buy in a shop, and there is nothing to it. But then they put it together in a way that gives you a sense of awe, artistic awe and appreciation, and you admire it and you get pleasure from it. And so that's the way I see interactions with other humans, with interactions with future versions of AI. It's all made of materials, but the way they were put together gives us an emergent phenomenon, something that goes beyond. It's sort of like an architect work. You put the building blocks of a construction of a building, you put them together, and at first, you look at the bricks. They don't look very different than bricks that you find in a shop or in a assembly line of bricks, and they each of them looks completely regular. But when the architect puts them together into a building, you can have a sense of awe and appreciation. So it's basically a feature associated with the complexity of the structure that was made. And the most complex structures that we know about are humans, and we tend to assign, a sense of spirituality to humans. But in my mind, it's nothing other than an emergent phenomena, just the way that AI comes out of silicon.
Interesting.
That's really interesting. AI is a funny one, and obviously it's an incredibly hot topic at the moment. There's beliefs. I think Elon thinks that ChatGPT has figured out a way of creating artificial general intelligence. You've got Elon Musk creating chips to put in the brain. What happens when the two combine? And do you think that there should be legislation in place to protect mankind from what could potentially happen once AGI is released on mankind?
Definitely. I do think we need to adjust the legal system to what is happening. It will not be obvious to many people that the AGI is here. And a lot of people have a vested interest in arguing that we are smarter than the machine. Because it gives a boost to our ego to believe that we are unique and special. That's why so many people argue that there are no aliens, that we are alone, because, this notion is much more comfortable. If we are superior to everything else, you can go to a restaurant and eat other animals. That's what you see on the menu. Why do we eat other animals? Because we think they're less intelligent than we are. If the chicken was smarter than us, we would have second thoughts of eating chicken. And so my point is, a lot of people are driven by a sense of superiority. I mean, and actually humans treat each other with that sense, which leads to all kinds of atrocities, and wars.
Agreed.
And why would one nation go to a war with another nation unless it felt that the other members of the other nation are inferior in one sense or another? All of these are human traits. We always want to feel superior, and so there is this denial that it will continue even when the future AI systems will actually do things intelligently better than humans. We would still argue, no, it's not really as good as an artist. It's not really as good as someone who composes music, because we still want to believe that we are superior. Okay, that is a tendency, and it will. So I'm saying that we will recognize AGI when it's already way above us. Not when it's comparable. When it's comparable, people will argue forever. Because if you look at people, there are other people that we think we are better than, and that's if that's the case, then it would also apply to the machine. Okay, so it's a natural human tendency to be driven in a direction of feeling superior relative to others. But eventually it will dawn on us, yes, they are better than us. And I have no problem with that, because I raised 2 daughters. I think those who are afraid of an intelligent entity doing what it wants, those are not good parents. Because as a parent, you'll get used to the fact that you cannot control other people.
I've got 4 children. I can't control any of them.
I mean, there are these parents who behave like helicopter parents, where they want to micromanage everything their kids do. But eventually the kids escape their home and become free. And I think we should allow the machine to behave that way. We should not micromanage it and become helicopter parents of AI systems. And we know how to deal with educating kids. You basically train them, you educate, you give them, you expose them to content that you want them to follow. That's called education. That's why we send kids to schools. That's why the government is involved in selecting the materials that is presented to them in school. You just don't send your kids to a dark corner on the street to learn from their experience what they should do, because that would educate a significant fraction of them to become criminals. And so when we take AI system, put them on the internet and let them scroll anywhere they want, it's equivalent to putting them on a dark corner of the street, because there is a lot of negativity online and you don't want them to be exposed. So my recommendation is that the legal system will force training on, just like the education system, on content that we want them to follow, content that we appreciate as being productive, constructive. And then we should, if they start learning on their own, we should at some point let them leave home and be their own, and expect them to do things that we cannot forecast, but hope that they will do it based on the guiding principles that we gave them. Just like my daughters, they left home by now, and I can only hope that they will be good citizens. I cannot control that. And so the same, now, of course, you can have a legal system that punishes those who violate some principles, and we have that legal system for humans. You can have that legal system also for AI systems. If they behave in a way that violates our principles, we can punish them by taking them out of production, out of use, or by punishing whoever created them. These should be decisions made by the government, and unfortunately the government is reacting very slowly right now. And of course, the physical world, as you mentioned, putting chip in our brain, a chip, I call it having a chip on our shoulder, so to speak. That would take more time. And the question there is different. The question there is, people who have chips on their shoulder or on their head, those people will be capable of doing better than people that just have the biological abilities. And the question is, how do you deal with that? Because, for example, if you have exams in schools or universities, you should give more credit to those who do not have chips. I mean, there should be somehow an adjustment. The entire education system will have to be revised, because each student may have an AI trainer that is suited for its needs, and you may not need actually people to teach. And there will be a huge number of changes to society. We're just starting. My recommendation is, instead of philosophy departments teaching ancient Greeks the way they're doing now, the way ancient Greek philosophers thought about ethics and other issues, those Greeks did not have computers. And my recommendation is, instead of dealing with humanities of the past, we should deal with humanities of the future. So I advise philosophers, social scientists, psychologists, to put their attention primarily to the challenge of AI getting into society and how to make it ethical and how to adjust the legal system and so forth.
I think that's a really interesting point, actually, because Tom and I saw earlier this week, we were talking about the Vatican and what they're doing at the moment, and they are in a process of updating their theological beliefs and their systems to get ready for the fact that we're not alone in the universe. And that's, for me, that's a massive step. And
right.
Tom and I will speak to the fact we believe the Vatican knows what's going on an awful lot more than they let on, but that's another discussion.
Well, so here is my point, that in order to learn something new, you need two qualities. One is humility. You should not assume that you know the answer in advance. You should be humble and therefore willing to learn, because I had in recent weeks actually experience with scientists who basically argued that the US government data is wrong and should not be believed just because their past knowledge cannot accommodate that. And to me, they are basically, those who prefer to abandon new evidence, new data in favor of past knowledge. That's a recipe for ignorance, and that comes from scientists, the scientific community. So I'm saying, if scientists are doing that, then anyone is doing that, and that's not a way to learn something new. And that's really unfortunate that you see that in academia, because science is all about being humble and learning. And the second is curiosity. You need to be curious, because if you say, "Oh, I pretty much know everything already, there is nothing really new to learn." And by the way, there was a scientist who said that 120 years ago. His name was Michelson, and he gave a speech at the University of Chicago, and he said, "Physics is over." That was the last decade of the 19th century. And he said, "Physics is over, and all that remains is for us to measure constants to the 5th decimal point, because we understand everything." And then a decade later, Einstein came up with the special theory of relativity, and a decade after that with the general theory of relativity, how gravity is related to space and time. And then a decade later, quantum mechanics was unraveled. So our entire conception of reality changed completely in the decades that followed Michelson's statement. And just to show you that he was not humble, he thought that we know everything. He was not curious, because already at his time, there were some questions, anomalies that were not understood. So if you are curious and if you are humble, you would definitely not call the possible existence of extraterrestrials an extraordinary claim. Why would you say it's extraordinary claim? I mean, there are hundreds of billions of stars like the sun in the Milky Way galaxy, and a quarter of them have a planet roughly the size of the Earth, the same separation. I would say that it's extraordinary to claim that we are unique and special. It's the other way around. Okay, but you would argue that we are unique and special just because you are arrogant. You think that there is nothing as good as we are. I look at the news every day, and it's obvious to me that there is a lot of room for improvement. We are not very intelligent. We are fighting each other, engaging conflicts. We don't listen. We don't pay attention to evidence, to data. All of these are traits of lack of intelligence, and I can imagine something better than us in space. And that's why I want to look for it. I want to see if I have neighbors, so that, if we have neighbors that are smarter than us, they will serve as role models. They will bring us to a better place. Mm-hmm. And that's the goal of my current research.
Tom.
Yeah, being that we're on this particular subject line, I guess this would be a good time to bring up our friend Roy's question. I guess by trade, Roy is also a theoretical physicist, mostly dealing in, as he says, abstractions. And he wanted us to ask you this question. He wants to know if you've considered conservational geometric symmetries applying independently of scale and to all emergent phenomena, providing a resolution for gravity and the phenomena as holding a relative faster rate of time than its surroundings, thereby negating the inertia of gravity?
Yeah, so that's a very important question of whether another civilization far more advanced than we are understands quantum gravity. We have theory of gravity that Einstein formulated, and we have quantum mechanics, but we don't have a marriage of these two pillars of modern physics. And in principle, there could be a propulsion system that is using gravity in a way that we don't understand. And just to give you an example, we know only of objects like the Earth or the Sun that are producing attractive gravity. Okay, but in electromagnetism, you have opposite charges. You have a positively charged particle and a negatively charged particle. So just imagine if there was a possibility for negative mass. Okay, so you put next to the Earth, you put another Earth with a negative mass, not a positive mass. What would happen? So the Earth would pull this object towards it because it produces attractive gravity. And this negative mass, Earth, would actually push the Earth away from it because it's producing a repulsive force, opposite sign. So you will end up with the Earth and this anti-Earth, opposite mass Earth, moving together. The negative mass Earth is pushing the Earth, and the positive mass Earth is pulling the other one with it for the ride. And they keep accelerating indefinitely up to the speed of light. And that's a propulsion system that doesn't require any fuel whatsoever. The only question is, can you make a negative mass? Now, we don't know. We know that the universe as a whole, the vacuum itself behaves as if gravity is repulsive. The vacuum has some mass per unit volume, and this is the so-called cosmological constant that Einstein came up with about a century ago. And basically, the vacuum itself is pushing galaxies away from each other at an ever-increasing speed. So it's a repulsive gravity that acts on the expansion of the universe right now. The only question is, can we take this vacuum energy and pack it in an object of a finite size? If we could do that, and for that we need to understand quantum gravity, then we could build an engine that doesn't require any fuel. Now, what Roy was asking is other possibilities that have to do with symmetries and so forth. That all comes together if you have a theory of quantum gravity. There would be some symmetries there that we don't fully understand. For 50 years, theoretical physicists have been working on an attempt to unify quantum mechanics and gravity. It's called string theory, but they have no experimental test. They don't even have a single theory. They have multiple possibilities. They don't make predictions that can be tested by experiments. So I must say that it didn't really advance our knowledge much because they cannot make predictions. They cannot tell me what happened before the Big Bang. They cannot tell me what is inside a black hole. And so unfortunately, we don't have that theory. If we meet a cosmic neighbor, out there that has a better understanding of quantum gravity, that's one thing we can learn. The first question I would ask is, what happened before the Big Bang? Do you have an answer to that? What's inside a black hole? Do you have, that's another benefit for having a smarter student in the class. You can always ask this student to give you answers to questions you don't know the answer to.
That was a really interesting response.
It's really interesting.
I'm pondering the engine with no fuel, and it makes so much sense.
There's so many different things about that, though. I mean, it's like you get to the ability to travel at that speed, and then time starts playing a massive role in this. You travel somewhere and you come back to where you started from, and 1,000 years have passed. And it's finding ways to overcome that as well.
Yeah,
so
I should have pointed out that if you accelerate at 1g, that's the acceleration on Earth, and you do it for 1 year, you will reach this close to the speed of light in 1 year, and it would feel just like being on Earth. If you are on a rocket that accelerates at 1g, it feels just like Earth. And if you continue to do that for 25 years or so, you can reach the edge of the universe because time will tick much more slowly in your frame compared to the rest. So even though for the rest of the universe, billions of years will pass, for you in your frame, it's just a few decades. So and if you come back to Earth afterwards, you would still be alive, but Earth itself, would evolve by billions of years, and the sun may die by then. By the time you come back, things will be very different, but you will still be around.
So our very good friend, mutual friend, mine and Tom's friend, Astral on Twitter put a question to put to you. Do you envisage a clear evidence threshold for definitively classifying something as extraterrestrial?
Yeah, it's very simple. If you find a gadget, technological gadget, that we can immediately see it was not produced by nature, and that's easy to tell, if it has buttons, it doesn't look like a rock, doesn't look like a bird, doesn't have wings, but it's maneuvering, or it landed somewhere on Earth, but it looks like a construction, something that was made technologically, but not naturally. And it's easy to tell that. And we know that it was not produced on Earth because, it either has, the material on it. There are various simple ways to figure this out. If you measure isotopes, radioactive isotopes that make this object, and they give you an age, a material age that is different than the solar system, you know that it couldn't have been produced on Earth, okay? If you look at several isotopes, they serve as clocks. And if several of them give you exactly the same age, which is different than the age of the solar system, it would be a conspiracy if someone were to plant these clocks that give you different age than solar system materials just for you to be fooled. So that's one example. But then, if it's a technological gadget and it represents technologies that we don't possess, like if you see ChatGPT 100, you press a button and it does things that you've never seen before. And then we can go around and ask the Chinese, did you develop something like that? Ask the Russians, you can ask anyone, because this would be, a big news around the globe, And so if no manufacturer comes forward and says, yeah, I actually made it, if it looks like there is a huge gap between what we are able to accomplish and what this thing represents, it will be clear that it's not from this Earth, or not from us, I should say. I mean, it's always possible there was someone else on this Earth before us that made such things that we should never exclude, but it will not be us.
I mean, we're seeing that already, aren't we? I mean, when we look at UAP sightings, and now they're trying to explain them away with the Arrow report, everything like that, we're seeing things in the skies already now that are far beyond our technological capabilities, yet they are still trying to explain it away.
Well, you have to understand that the objective of government is national security. And so people in government are trying to behave like the adults in the room, meaning that the default for them would be to say, we understand it, it's nothing important. I mean, as long as it's not an adversarial country doing it, they will just dismiss it. Because they're not a scientific organization. We should not ask the government to figure out what's in the sky for us. That is the role of astronomers like myself, scientists. And that's why I established the Galileo project, where we built one observatory at Harvard University that is already looking at the sky 24/7. We have a second one being assembled in Colorado right now, and hopefully within a few months we'll start getting data. And then another one that we just got funded by the Mellon Foundation to establish in Pennsylvania. So altogether, within a year, we hope to have 3 observatories monitoring the sky all the time. The first one at Harvard is giving us hundreds of thousands of objects already within a few months. So far, we haven't seen anything unusual, but even if 1 in a million objects happens to be from outside of this Earth, that would be big news, as we discussed. So, I think without searching, you will not find anything. And secondly, we shouldn't rely on government to tell us what's in the sky, because the sky is not classified.
Agreed.
I love that.
Agreed.
Sky is not classified. I mean, is it, at least in your mind, obviously UFOs appear to have been here with us for a very long time, and people's perceptions could be different now, but I mean, the reports have been through the millennia, essentially. Digby and I were talking the other day about Alexander the Great and his army, seeing these two flying shields that came down and swooped at them. Do you ever think about the possibility that we're dealing with a force that is so intelligent and so elusive that if it wants to be seen, it can be seen, and maybe, and then the opposite? Like, what if it's something that can absolutely circumnavigate any attempt that we have to gather evidence on it? Because, if we can't gather that evidence, a lot of people are going to write it off, right? A lot of people are going to be like, well, maybe it's not real. But what if we're dealing with something that has the ability to do that? Like, how do we navigate those waters?
Right. So first, I should say there is always a chance for space trash, okay? Because we sent out things that will not be functional in a short while. I mean, Elon Musk sent the Tesla Roadster, which is a car that he owned, using yes. Falcon 9 as a payload, dummy payload, in 2018, and it's now on an elliptic orbit. And in the future, some astronomers calculated within tens of millions of years, it will collide with Earth or the Sun, and then it will appear as a meteor, okay? It will not be functional. And I'm sure that if it would do it unexpectedly, some of my colleagues would argue that it's actually either the data is wrong because it doesn't seem to fit what they are used to in terms of rocks, which is basically what they said about the interstellar meteor that I studied recently. So they would say the data is wrong, if the government detects it. But beyond that, if it behaves in ways that that appear to be unusual and they trust the data, they would say it's a rock of a type that we've never seen before, even if it's a Tesla Roadster car. But we should allow for the possibility that there is some space trash, just like plastics in the ocean. It accumulated over billions of years in the interstellar space of the Milky Way galaxy, and those objects, trash, they move at a speed that does not allow them to escape from the Milky Way, so they are bound to it by gravity, and they keep accumulating over time, and there must be some population of those guys. So this is a simple way of finding that we have a neighbor, just by finding something like a tennis ball thrown by a neighbor. It's not doing anything, but you realize that the neighbor plays tennis, and so we should allow for that. And that includes objects that collide with Earth and appear as meteors. That's why I'm interested in finding interstellar meteors that came from outside the solar system. Maybe not all of them are rocks. Maybe some of them are technological gadgets that are not working anymore. It could be that Oumuamua, this object that did not collide with Earth, that was the size of a football field, was also space trash like that, like a piece or a surface layer of a bigger object. So these are objects that we can find, and they cannot avoid us because they don't function anymore. Okay, and that's the way our probes will behave, like Voyager, when they exit the solar system. They will not be functional in 10,000 years. They almost lose their functionality right now. So that's one way to deal with it. Another one is something that I had a podcast interview on Friday, and the interviewer said, well, maybe we should just broadcast a message and say, please reveal yourself if you are nearby. We want to see you. If you're playing seek and hide, we would like to know that. Now, usually when you transmit a message, to the stars, it takes a huge amount of time for it to reach the stars. They're only within 100 light years, which is the distance that our radio transmissions reached over the past century. There are only hundreds of stars that could potentially respond to this message. But so that's why we don't hear anything back, probably. But otherwise, if you want a much larger population of stars to be aware of us, we have to wait millennia and thousands of years. And so that's a long time, unless we have a visitor in our backyard. If you have a visitor in your backyard, you can establish a conversation. Okay, so that's the importance of finding something functional near us, because then we can maybe learn about it and interact with it. And But as you say, the evidence, these things are evasive. We don't really know at the moment. The way I approach it is to just search the sky without assuming anything. And if something is not familiar, if, we just need to search for things that do not look like the objects we are familiar with, like birds, drones, balloons, airplanes, satellite. If there is something else out there, let's get as much information as we can.
Yeah. And what you're saying there about, sending out a radio signal and it taking 40, 100 years to get wherever, we also have to take into consideration that it might reach a civilization that are sort of on the same path as we are, have the ability to send a message like that out, but don't necessarily have the ability to travel. Then we have to take in the fact that they want to send a message back to us. It's going to take another 100 years to come back the other way.
Incredible.
Exactly. That's not a good way to establish a relationship. I mean, some people have long distance relationship, but it's never that long of a distance.
That's a little too long.
Yeah, so if you have a very long distance relationship, it's equivalent to you being single. That's my point. It's not really a relationship. Don't fool yourself.
So I think since we're talking about sending objects out into space and instruments and such, we actually have a really good question from someone named Nurse Diesel, also on X. He says, if you had the opportunity to send a spacecraft to intercept and study one of these interstellar objects up close, what specific scientific instruments or experiments would you prioritize on board, and why?
Well, definitely an imager, like a camera that gives me a view of what this object looks like when you land on it. And then I would like to have a robot that can do things. If there are buttons there, let's press a button and see what happens. If there is something we can take away from it, the way we took, for example, material from, there was this mission, OSIRIS-REx, that took material from the asteroid Bennu and actually brought it back to Earth. And that would be amazing if we can do that. Even if it's a screw, if you can just unscrew something there and bring it back to Earth, I would like to look at that screw. But in general, it's really the most important thing is to image it, because even an object as big as a football field looks like a dot, a point, for all the telescopes on Earth. And that's why we couldn't really get a sense of what Oumuamua looks like. There was only an artist illustration, and we just measured that the amount of sunlight reflected from the object changed by a factor of 10 as it was tumbling every 8 hours. And that meant that it has a very extreme shape. And when people try to model the shape, it was most likely flat, like a pancake. Oumuamua was unusual, but we didn't have an image. And I would love to, obviously, when you have an image, you can tell what it may be. It's easy to differentiate between a rock and a membrane, a sail, a surface layer. The key instrument would be an imaging instrument, and then secondary would be something physical, like a robot that can go on the surface of this object. And I wonder if it goes into a door, what happens? Like opens the door and gets in.
That'd be quite a sight.
By the way, I should clarify that if I ever get an opportunity for a one-way trip, a one-way ticket away from this Earth, I would take it.
I'm coming with you.
Really? Well, when we go to Mars, you might be able to sign up. I think they'll let you on.
Well, we should see.
I think your credentials would match up. We'll have a chat with Elon Musk.
I think you qualify.
Absolutely overqualified. Right, what's next, Tom? Have you got another question?
Yeah, this is kind of an interesting one that I had thought of. Being that we understand, understand is kind of a strong word there. We think we understand certain properties of the quantum level, things like superpositioning and such. I'm wondering, do you feel that it's possible that maybe some of what we're witnessing with these objects, if they are non-human, could they have maybe found a way to take the principles and laws that we see at play in the quantum and have figured out a way to bring it to the macro? Like, how likely is that?
Well, that's we already do that. We are doing that because many of our gadgets are based on quantum mechanics. Like even the cell phone that you're using and the computer that we are using to communicate, we are taking advantage of quantum effects. And of course, those effects are dominant at the atomic level, on the small scale, but they can definitely be engineered to affect bigger scales. Just to give you an example, the universe did that. When the universe started, quantum effects were very important early on. And the most popular theory for the origin of all the structures that we see in the universe, like the Milky Way galaxy, inside of which stars like the sun formed, near which the debris left over from those stars made planets like the Earth, on which life as we know it emerged. All of that complexity that we find, including life, intelligent life today, according to the popular model of cosmology of the universe, the early universe, it all started from quantum fluctuations at very early times, when the universe was a fraction of a second old. Those quantum fluctuations introduced the small inhomogeneities in the universe that grew over time and became the objects that we see today. And this is an illustration that quantum mechanics not only started the process, but actually led to the formation of big objects like galaxies, like stars, like planets, like on which we have a life now. All of this started from quantum mechanics, quantum mechanical fluctuations. So we owe our existence in this way to quantum mechanics, and I wouldn't be surprised. We just have a century of science and technology since quantum mechanics was discovered, that in the next century we will find ways by which we use quantum effects. And already we are talking about quantum computers. You see that is using quantum mechanics for computing, but it will find many other ways, because quantum mechanics is really ruling the reality that we live in, even though we're not used to it. It's counterintuitive in many ways. But I'm sure that the engineers of the future will apply quantum mechanics in bigger ways and affect the quality of life of all of us.
What would you say then is, what project have you got going on at the moment, whether it be an experiment you've got going on or whether it's the work you're doing with the Sol Foundation? What do you think will bear the most fruit?
So we are, right now we are planning the next expedition to find the bigger pieces of the first interstellar meteor that was discovered a decade ago by sensors aboard the US government satellites. And those satellites, you have to understand that this network of satellites did not exist more than a decade ago. It was put in place to detect the heat from the launch of ballistic missiles, to warn the US president from a threat, let's say from North Korea. And they do it in a fraction of a second. So you have this network of satellites around the globe. And a decade ago, they detected a fireball equivalent to a few percent of the Hiroshima atomic bomb energy output. And they looked at the data and realized it's actually a meteor. It's an object half a meter in size that collided with Earth. So they said, okay, this data is of scientific value. We don't care about it for national security. And so they put it on a catalog that NASA put online. It's called the CNEOS catalog of meteors. And there are 273 such meteors listed there. And so it's one of them. And then I realized, together with a student of mine, that indeed this object was moving so fast that it came from outside the solar system. And the US Space Command confirmed that in an official letter. Members of the research team looked back at the data to validate and said that the 99.999% it came from outside the solar system. So this was the first reported interstellar meteor. We went to look for materials from this meteor. We found tiny droplets, less than a millimeter in size. About 10% of them showed composition, chemical composition, that was never reported in the scientific literature for solar system materials. So it may well be materials from an object that came from outside the solar system. And what we hope to do is have another expedition in the coming year to find bigger pieces, because they can tell us whether the object was a rock or something else. And they can also allow us to date the age of this material. Now, this expedition will cost about $5 to $6 million. We already have a ship that we identified. We have a plan for the machinery, for the equipment that we will use. It will include a video feed. It will include a remotely operated vehicle. The priority right now is to get it funded. And if anyone listening would like to provide the funding and join the expedition, it will be a very nice ship, actually, that goes there.
Well, I'll happily go on the expedition, but I haven't got any money. But we
is there
ways that people can help?
It will not happen if we don't get the money. That's my point. I mean, that will be very exciting. We now know where to look for those bigger pieces, because we found the tiny droplets that melted off meteors in that region. And so then we have a second task to look for the second interstellar meteor that was in a different location. The first one was in the Pacific Ocean, the second one in the Atlantic Ocean. And we hope to do that as well in the coming year. So 2 interstellar meteors. Let's see if one or more than one might be artificial in origin. That's what we are hoping to find. It's a lot of work, I should say, to plan and execute those expeditions, but it's definitely worth it.
So, talking about the funding, I mean, first of all, what was the funding mechanism for the first expedition that you did? And secondly, what have you got in place for this? Is there if anybody's watching, is there a GoFundMe or something like that? Can anybody help with crowdfunding? How can people get involved?
Right. So in the first case, I appeared on a podcast like this one, and then mentioned the fact that we hope to go to the expedition. And I got an email from a person Charles Hoskinson, who arranged a Zoom call and said, you have the money. He was inspired by the mission. It was $1.5 million, the first one. Mm-hmm. This one is a few times more expensive because the instrumentation that we will use will be more sophisticated. We didn't have a video feed in the first one. We didn't have a remotely operated vehicle in the first one. But just because we want to get bigger pieces, we need this better equipment. And my hope is that someone would get excited enough to fund it, and then I can promise that we will do the best we can to justify the trust of that person. We are committed to doing first-class work. We have the best engineers and navigators and scientists in the project waiting to do the work as soon as we are funded. And for small donations, we do have on the Galileo Project website at Harvard University, we have a button that says support us. So anyone that wants to support it at a low level is most welcome. But we really need a contribution at the level of $5 million to make this expedition. We very much hope that someone will be inspired, as happened to be the case in the first expedition, where, it was a very successful expedition. We did find what we were looking for, and all the stars were aligned in some sense, because it required, an exceptional team to accomplish that task. If one item would not have gone correctly, we would have not found anything. Like if the sled with the magnets that we used would not stay on the ocean floor and would kite above it, we would not collect any materials. and if I didn't get the attention of one of the best geochemists in the world, Stein Jacobson, we would not identify these unusual materials that we found thanks to his laboratories. It took us 8 months to do the work. So altogether, I hope that the second expedition would be as successful as the first one.
Well, Tom, this has just reminded me of a conversation you and I had, what was it, about 4 or 5 months ago, with a guy that I know in the UK who has investors worth tens and tens and tens of millions of pounds, and they were looking at investing some money in projects that would make a difference in this arena. So I will reach out to them and speak to them on your behalf. I can't promise it will bear any fruit, but
I was
so much.
they're
going.
Probably worth the effort, though.
It's probably worth the effort, so I will make the call. But
Absolutely.
if I do, I'd like an honorary place on the ship.
Oh yeah, the matchmaker is usually invited to the wedding. But I should say that if speaking with me would help, I'm happy to describe the details to such a person.
Well, I've got your contact details and everything, so yeah. I will make a call this afternoon, and I'll let you know what he says.
Thank you.
Because they were, weren't they, Tom? They were talking about considerable amounts of money, and they really wanted to get ahead of the curve with
they were serious.
The whole UAP subject, because they realized
it makes me wonder as well. What's taken us so long, Professor? Like, why all the movement now? These are things that there should have been an Avi Loeb 50 years ago that tried to do something like this. Does it really just come down to the money?
No. Okay. Well, I can tell you what could have prevented people before me from doing it. If you were to take a younger version of myself, of me, before I had tenure, before I had the job security, before I had the confidence that I have now, after leading so many initiatives and centers, at Harvard and beyond, it would have been very easy for people to derail my mission, because they would just dismiss it, ridicule it, and I wouldn't get anywhere. And you can see those people trying to do it now. I mean, for me, it's completely appropriate for someone to say, to tell me, I'm too busy, I cannot really get engaged in the study of these anomalous phenomena. But they go well beyond that. There are people who dedicate day and night to just criticize the work that I'm doing, that my team is doing. So they're not doing any substantive work. They don't have access to the materials that we collected, yet they have criticism. And this negativity, this toxicity explains to you why it's so difficult to do the work, because not only that you have to invest time and effort, but you have also those critics that do nothing except for ridiculing it. And that I find to be counter science. These are anti-scientists because they resist the scientific method of collecting evidence and analyzing it, studying it, which is the way that we make progress in our understanding. And there is no question that is more important than, are we alone? Do we have a neighbor from whom we can learn? And all I'm saying is we should check our backyard if there are any objects, because in the past we searched for radio signals, but that's just like waiting for a phone call. Nobody may call you when you're waiting. However, packages may keep piling in your backyard, over time. And so this was never done before. And the UAP research, was not pursued. And now I think we have the instruments. We can do the work. We don't need to rely on government to tell us what's out there, because they don't have the scientific credentials to do it, frankly. So I'm trying to bring this to the mainstream, and I'm doing my best to put the hard work into it. And the only under these circumstances, the only thing that remains is to get it funded.
Yeah. Well, I think you're doing a fantastic job, personally, of bringing this to the masses. You're a very well-respected voice within the community, and it means a lot to all of us that you took the time to speak to us today. So I personally thank you for that. And
Thank you.
I'm sure everybody will
well.
that watches it as well. I know you've got somebody coming to see you, so we won't take much more of your time. But Tom, do you have a last...
I have a poet that wanted to meet with me in a few minutes. He's visiting Cambridge, Massachusetts, and he asked the host to speak just with one person at Harvard University. One person that he wanted to speak with is me about extraterrestrials. And I find that fascinating. We should see what he wants to say. Yesterday, I had a filmmaker that came to meet with me. Every day, I think this subject as a whole is appealing to a huge number of people out there. And because of the stigma, because of the bullying, they're afraid to speak out. But I mean, I think that there is a lot of support. And once we find the evidence, the material that demonstrates the point, everyone would say, yeah, of course, we thought about it for years.
Yes,
right.
Of course.
That's what I expect. That's it.
We need a few more David Grushes to come forwards to pave the way for the excitement of the rest of the general population, I think.
Exactly.
Yes, we do.
Thank you for hosting me. It was a real pleasure, and let's keep the conversation going.
Yeah, absolutely.
I totally agree. And Professor, is there a good way that everyone watching can keep in contact with you through social media and follow your work? What's the best place to find you on the internet?
Right. So I'm not on social media. I just don't have time for that. But I do post on medium.com. If you just look for Avi Loeb at medium.com, there is a site where you can subscribe to my updates. Every day or two, I write an essay, and they are free. I don't charge anything. I don't make money out of this. And you can follow my work just by subscribing to Avi Loeb at medium.com.
I have one article that I wrote on there right before one of the reports came out, so I'm going to have to catch up with you.
Oh, thank you. Yeah. So, yeah, there were some interesting ones over the past week. Check it out. There would also be a video coming out from Harvard Magazine, the official magazine of Harvard University, hopefully in the coming week, about the work that I told you about.
Nice.
Fantastic.
Brilliant.
I'm literally blown away to even be here with you. You're one of my favorite people.
I should also mention that in 2025, my hope is there will be a Netflix documentary, because they already filmed the expedition.
Really?
Yeah. So there are lots of things to come. I'm starting to write the next book. Actually, there is a children's book that I agreed to also write about the expedition.
Oh, good for you. That's really great. We got to get the younger generations involved too.
And one more thing. Tomorrow, I'm speaking with the managers of a theater nearby, because someone wrote a play about my work, and we want to show it. So if they agree, it may show in the coming year about the research that I'm doing.
Oh, that's
Avi, you're
fantastic.
a superstar. You're an absolute superstar in all the ways possible.
He's a rock star, man. That's great.
Yeah,
I love it.
You are a scientific
Avi Loeb on ice.
Yes. I'm going to clip that.
That's great.
But just keep in mind, I'm a farm boy. I haven't changed since the time that I was on a farm. People who know me from back then say that I haven't changed at all. So that's the special quality that I maintain, the staying like a kid, basically, and enjoying
it.
That's
I love seeing that, because that's how I feel about life, personally.
Right.
Thank you.
I'm going to get off this interview now and make a phone call on your behalf. So I will.
Thank you so much.
No problem.
Keep me posted.
Thank you.
I will do.
Thank you very much.
We get the chance to speak to you again soon, and enjoy the rest of your day.
Thank you. Bye-bye.
Thanks, Professor.
Thank you for watching this episode of the Unidentified Anomalous Podcast. If you like what you saw, please remember to hit that subscribe button and like the show. It really makes the difference to both myself and to Tom, and helps the show reach a wider audience. So from both of us, until next time, take care. Bye-bye.